Okay, today we're going to go ahead and begin our Unit 14 foldable, which are effects on functions. The good thing is we've been working on graphing a lot, and these are kind of the same thing. It's going to be functions we've already done. We're just going to kind of move the graphs around and change them a little bit. So go ahead and take the time, copy down the parts that you need for your foldable for the tabs. We'll have 4 tabs. The last one will be blank, so you can feel free if you run out of room to copy it on the last tab. Our first tab that we're going to look at are vertical shifts. If you think of the word vertical, that means up and down. So we're simply going to talk about how you can take a graph that we've already done and you can simply move it up or down. So you can translate it or shift it up or down, and it ends up happening by just doing something within the function. So let's take a look. We're going to have a couple things in our foldable, a couple graphs to draw, so save a little bit of room for it. Okay. First thing we're going to look at, we're going to take 2 graphs and we're going to see what happens when you do something to the end of the graph. Okay, so if you notice the first graph, the absolute value of x minus 2, we just talked about that absolute value ends up making a v-graph. If you look up here, the vertex of it, we call it a kind of a vertex. The opposite of 2, the opposite of negative 2 is 2. And if there's nothing on the end, it's 0. So it should kind of have a vertex or a point where it happens at 2, 0. So let's go ahead and take a look at that real quick. So I'm going to go ahead and put it up there. So there's our graph. You may want to copy it down. So you can see at 2, 0 right here, you have a vertex and it ends up opening up. Over on this graph, the only thing that's different, you still got the x minus 2 part, but you have a plus 2 at the end. So when you have a number that's added or subtracted all the way at the end of a function, what it's going to do is it's going to shift the graph up or down. If it's positive, it moves the graph up. If it's negative, it would move the graph down. So by adding 2, what should happen is this graph right here, okay, my first graph, should be shifted where the vertex moved up 2. Okay, and so let's look at our new graph when that happens. Okay, so if you look, this new graph simply got shifted up 2. So now the new vertex, instead of 2, 0, ended up being 2, 2 on this. But the whole graph was shifted up 2 by simply adding 2 at the end of the function. If I would have subtracted 2 at the end of the function, it would have moved down 2. If I would have added 5, okay, the graph would have moved up 5 and so on. Okay, but vertical shifts are really easy to deal with. For our next slide, what you'll see, we have the equation f of x equals 3x. Okay, so this is an equation of a line. So if you want to kind of get a visual idea of it, pretend there's a 0 on the end, so I have plus 0. So I have a y-intercept of 0, and I have a slope of 3 over 1. So when I normally graph that, if you remember, you'd put a dot on the y-intercept on 0, and then you would go up 3 over 1, up 3 over 1, and your graph would end up looking like that. Okay, so y-intercept of 0 right here, and again, I would move up 1, 2, 3, and over 1, and that would give me a new point on my graph. Okay, just a little refresher on graphing. If you notice on here, the only thing that's different between f of x over here and g of x over here is this minus 3 at the end. The 3x stayed the same. All they did is they subtracted a 3 at the end. So again, since they did something outside of the graph at the end, it's going to move it up or down. So this line should move down 3. Okay, it should be shifted down 3. So an easy way to look at it, what it should look like. Here's my y-intercept. My new y-intercept should be down 1, 2, 3. Should be down here when they draw the new line. So let's see if that happens. Okay. You can clearly see now it's the same line, but now it has the new intercept of negative 3. It was shifted down 3. But that's all you're doing. Again, when a number gets added or subtracted, at the end of the original equation, it just shifts the graph straight up or straight down, depending on if you add or subtract. All right, for our third slide, we have f of x equals x squared. You should know that's a quadratic problem, so it ends up making some type of u. So let's go ahead and look at that. Okay, so there's our u. And what we're doing over here is a little bit different. It says, let g of x equal f of x plus 4. Okay, again, you are adding a number at the end of the function, okay, separately. So that should mean that graph is going to shift up 4 units. Now they put f of x there. If you want to know the equation of the graph, we already know f of x is x squared, so you can simply replace that with x squared plus 4, okay, if you want to relate it to that. So it's just saying, let g of x equal f of x plus 4, and we already knew f of x was x squared, so I just filled it in there. But in general, okay, when I add or subtract a number at the end, it's going to shift it up or down. So if you look at the vertex of this graph right here, that new vertex should be shifted up 4 units from my new graph. So let's take a look at it. Okay, so I have it shifted up 4 units. So in general, when you have a number at the end, we'll call k. You move up if k is positive. You move down if k is negative. But that's all. The graph doesn't change. It'll look the same. It's just getting shifted up or down. The only thing that changes on the graph are the y values. They get moved up or down. Okay, that's the only notes that you're going to need on that part of the foldable. I do want to go over some other problems where you're going to get asked questions at the end of Edpuzzle. And these are going to help you a lot for your homework. All your homework questions are going to look similar to this. So what I have is I have 3 tables here, and they're all related. So this will go faster than you think. You could use your calculator to make a table, but if you follow the way I do, you'll be way faster getting it done. So let's look at our first function. It says f of x is equal to the absolute value of x minus 3. So you can do this one by hand. You don't need a calculator. I'm going to fill in these x values into the function, and I'm going to just write the answers that go with them for f of x. If you remember with absolute value, all that means is when you fill in a number, the absolute value is always going to be positive. So I'm going to put a positive answer for each one of them. So right here for my first one, when I fill in 1 for x, 1 minus 3 is negative 2. The absolute value of negative 2 is positive 2. When I fill in 2, 2 minus 3 is negative 1. The absolute value of negative 1 is positive 1. When I fill in 3, 3 minus 3 is 0. The absolute value of 0 is 0. When I fill in 4, 4 minus 3 is 1. The absolute value of 1 is 1 again. And when I fill in 5, 5 minus 3 is 2. And the absolute value of 2 is 2. So notice how you have the quadratic pattern, which you'll always have with the absolute value, whether it shows up in the table or not. Let's look at our second function. It says let g of x equal the absolute value of x minus 3, and then on the n plus 5. Well, we already know the answers for the absolute value of x minus 3. They're all right here. So I'm simply going to add 5 to all of those. It's saying take all those y answers, okay, which I get right here, the f of x part, okay, and it says add 5. So that should shift everything up 5. So I can simply look at this and add 5 to each one. So instead of 2 over here, I know I'm going to add 5 to it, so I get 7. Instead of 1 over here, I'm going to add 5 and get 6. Instead of 0, I'm going to add 5 and get 5. Instead of 1, I'm going to add 5 and get 6 again. And instead of 2, I'm going to add 5 and get 7. So all I did was take all these y values over here, and I added 5 because I had a plus 5 at the end. So yeah, you can waste your time using the table in your calculator, or you can simply think about it. You're just adding 5 to each answer. Let's go to the last one over here. Again, h of x equals the absolute value of x minus 3, which was in graph 1. And it says I'm going to take away 2. So again, here's all my absolute value of x minus 3 answers. And all it's saying is take away 2 from each one of them. So I have 2 for the first one. When I take away 2, I have 0. I have 1 for the second one. When I take away 2, I have negative 1. I have 0 for the third one. When I take away 2, I have negative 2. I have 1 for the fourth one. When I take away 2, I have negative 1. And I have 2 for the last one. When I take away 2, I have 0. Okay? So again, if you pay attention to what's going on, when you shift a graph up or down, it's just changing the y values. The x values are staying the same, but I'm just doing something to each of the y values, which makes it an easy problem. Let's scroll down and look at a few questions then. Okay, first of all, number 1, it says, how can the graph of f of x be changed to get the graph of g of x? Well, if you look up here, what I ended up doing to go from f of x to g of x is I added 5 on the end. So your answer should be you had a vertical shift up 5 units. Okay, you took the graph of f of x, and you had a vertical shift up 5 units. Okay, and that went from f of x to g of x. Okay, the second question, how can the graph of f of x be changed to get the graph of h of x? So let's go back up. So f of x again is at the beginning, and if you look at h of x, you subtracted 2. So what do you think you did? You vertically shifted f of x down 2 units. So you had a vertical shift down 2 units. Okay, the third one, how can the graph of g of x be changed to get h of x? It's a little bit different, so go back up here. Now we're talking about g of x, and we're talking about h of x. This one's a little interesting. Look at your graph here. You had plus 5 at the end, and you went down to -2. So you went from being up 5 to being down -2. The difference between 5 and -2 is you went down 7. Okay? Because this graph was 5 units high. Okay? Now it's 2 units low. So you went from being 5 up all the way down to -2. So you went down 7 units. So a little bit different. You went total of down 7 units to get from this first graph g of x to the second graph h of x. Okay, so you went with the vertical shift down 7 units. Okay, our last question down here. It says, suppose I wanted to create a new graph in R of x in which I shifted h of x down 10 units. Write an equation for R of x. So let's go down, look at h of x again. H of x is the absolute value of x minus 3 minus 2. So I'm going to write that. So h of x is the absolute value of x minus 3 minus 2. And if I want to shift that whole graph down 10 units, again, I would simply subtract 10 at the end. Okay, and that would shift that whole graph, whatever it was, down 10 units. So at the end, that new R of x graph would be x minus 3 minus 12. Okay, x minus 3 minus 12. Another way they sometimes write it, okay, R of x could equal the h of x graph, okay, that we were talking about, and they just want it shifted down 10 units, so I could also write it like that. Pay attention to your directions. It has you write it one way or the other. Okay, but I could actually put the whole function minus 10, so I'd have minus 12 at the end. Or you could say you would take the h of x graph and just subtract 10 away to shift it down